Base catalyzed eliminations are also possible, where we use OH- and heat, and we saw some of these back in test 2. I've presented this one here as an E2 type mechanism, but E1s are also possible, again for secondary and tertiaries, but not for primaries. Alright, let's take a look at a couple of examples of those. You already saw on the previous slide a secondary that had an E2 type mechanism. Let's take a look at an E1 type mechanism. So we're using OH- and heat, and the product will be this, and we'll have Br- and water as byproducts. So looking at the E1 mechanism, what's going to happen first is that the Br is going to leave, and it's going to leave a positive charge on that C, and we'll have the Br negative coming off here, and then BOH minus will come in and we'll get our alkene product. So just in summary, secondaries and tertiaries can undergo E1 or E2. And remember, we saw E2 on the PowerPoint slide. Let's look at a primary example of an E2. And there's our product. And looking at the mechanism, we'll have the H down here. It's always the CH next to the CBr, just like it was the CH next to the COH that was lost in those other examples that we did, the acid catalyzed dehydrations. Alright, so a one-step process, leaving us with water and Br minus as products, and our alkene. Now keep in mind, this can't undergo an E1 for the same reason that the OH couldn't. So if we try and get rid of the Br in the first step, what we'll end up with is a primary C+, which is going to be incredibly unstable. That can be avoided by having the OH- take the H, form a double bond, and remove the Br all in one step. So no carbocation ever gets formed in that instance. So again, secondary and tertiary, E1 or E2, primary can only go E2 mechanisms.